So we got a really great do now today is we're going to start working on some Pythagorean theorem word problems. So our do now, if the area of a square is 144 meters squared, what is the length of its diagonal? Okay, so that's a lot of missing information there. Let's start with what we do know. We know we're talking about a square. We know its area is 144 meters squared. We're looking for what is the length of the diagonal. So we put an X there, our unknown. Now we need to bring in some other information we know about our squares. We know squares have 90-degree angles. We know all four sides are congruent. And we know the area formula of a square is side squared. So if the area is 144, that must mean that 144 is equal to the side squared. So take the square root of both sides. Now we know the side length is 12. So we've got 12 meters all along the side lengths. And we're looking for the diagonal. That diagonal in our square creates a right triangle, right? Where we have side lengths of 12 meters and 12 meters. We're looking for the diagonal. We're looking for the hypotenuse. From here, now we can use our Pythagorean theorem. A squared plus b squared equals c squared, where both legs are 12. So 12 squared plus 12 squared equals x squared. 12 squared is 144. So that's going to be 288 equal to x squared. Okay, so now we're going to have to work to find what x is. So we'll take the square root of both sides. So as we're trying to find the square root of 288, I might realize, well, 288, that biggest perfect square factor is going to be 144, right? 144 times 2. So square root of 288 simplified is actually going to be 12 rad 2. So there we go. There's our answer in simplest radical form, 12 rad 2. So the length of our diagonal would be 12 rad 2 meters. Or if we wanted to find our answer not in simplest radical form, square root of 288 would be 16.97 meters. And I just wanted to show both options there so you get a feel for the numbers. Here we are on page 18 in our booklet, and we're going to start by just solving an algebraic equation, and we're going to leave our answer in simplest radical form if we need to. Okay, so we're solving for x. We're first going to isolate that variable term by adding 15 to both sides. So we have 3x squared equals 75. Then we'll divide both sides by 3. So we get x squared equals 25. Take the square root of both sides. Then x is going to be, now we always say the square root of 25 is 5. Little side conversation for us here. So we're going to say this is a perfectly acceptable answer for 7th grade. But as we go to high school, okay, so when you go to high school and we're looking at this stuff in a different context where we're not talking about geometry and we're just talking algebraically about numbers, we really break this problem down a little bit of a different way. And I'm just going to restructure it here. So when we have x squared equals 25, we're really saying, well, what number times itself would equal 25? And we know that 5 times 5 equals 25. And this works great for 7th grade also because we're talking about Pythagorean theorem. We're talking about triangles where our integers must be positive. But isn't it also true that -5 times -5 also results in 25? And that is true, and that's a great algebraic use of our square roots, okay? That a square root could also possibly be negative. So when we're talking in high school, if we're talking in an algebraic context, not a geometry context, not something concrete that we can build with, we would say that our answer could be 5 or it could be -5. Okay? And that's just a little preview of an extension for you guys, something you'll see in high school. But like I said, in 7th grade, my expectation really is that we're saying 5. Square root of 25 is 5, because our whole point of working with these radicals and simplifying our radicals was really to build with that context of the Pythagorean theorem in geometry, where we are using positive integers. Okay, so let's go back to our geometry here. We're going to solve a word problem. We're going to draw a picture for it. So we've got a 20-foot ladder is leaning against a house. The bottom of the ladder is 3 feet from the house. How high up the house does the top of the ladder reach? Round to the nearest hundredth. So let's go ahead, let's draw a picture. It could be as detailed as you want, or just kind of like our basic triangle there, but let's take a second to do that. So I had some fun with it. I drew my house there, but the part of the diagram we really want to focus in on is the right triangle that's created. So we have to know that the side of our house is perpendicular to the ground. It creates a right angle. And then let's put in the information from our diagram. A 20-foot ladder is leaning against a house. So that's our ladder leaning against the house, and it's 20 feet. The bottom of the ladder is 3 feet from the house. Here's the bottom of the ladder, and it's 3 feet from the house. Obviously, this isn't drawn to scale. We want to know how high up the house does the top of the ladder reach. So how high is that? So I'm going to put X there. So from filling in our diagram, we can see we have a right triangle with legs of 3 feet, X, and a hypotenuse of 20 feet. So we're going to use our Pythagorean theorem. This is really sort of a classic Pythagorean theorem word problem. Substitute in. So we've got a leg of 3 feet, 3 squared. We've got a leg of X, X squared, and our hypotenuse, 20 squared. So we'll do our exponents first. 3 squared is 9. 9 plus X squared. 20 squared is 400. Subtract 9 from both sides. So we'll get X squared is equal to 391. Now we want to know what X is. We're going to take the square root of both sides. So we get X is equal to, our directions are round to the nearest hundredth. That tells me take my calculator and actually find out the square root. Square root of 391 rounded to the nearest hundredth is going to be 19.77 feet. It is 19.77 feet up on the house. Okay, so go ahead, you guys, you're going to do the word problems on page 19. Remember, our review sheet also became available today, so you want to be working on that. That's going to be due Thursday by 9 p.m., and an answer key will be available on Thursday so you can check your work. Tomorrow, we're going to have an Ed Puzzle video having to do with our review sheet, and the following day with sort of how to access the test on Friday. Okay? Have a great day. Our math jokes for mathy folks. Have you heard the latest statistics joke? Probably. Haha. Get it? Statistics, probability, probably.